How do algorithms function? Much of what we do in our daily lives is based on an algorithm, a series of step-by-step instructions designed to produce results. Algorithms are widespread in the digital world. They're a critical component of any computer program, built into operating systems to ensure our devices follow the correct commands and deliver the desired results. An algorithm is a computer-coded formula that, when activated, prompts a technician to take appropriate action to solve a problem. Input and output are used by computer algorithms. When data is entered, the system analyzes it and executes the appropriate commands to produce the desired result. A search algorithm, for example, responds to a search query by attempting to retrieve the relevant information stored within the data structure. An algorithm is made up of three parts. Linear sequence, the algorithm goes through tasks or statements one by one. Conditional, the algorithm chooses between two actions based on the conditions set. For example, if x equals 10, then do y. Loop, the algorithm consists of a series of statements that are repeated a number of times. The goal of any algorithm is to eliminate human error and arrive at the best solution as quickly and efficiently as possible. Data scientists, developers, analysts, and statisticians whose work relies on the extraction, organization, and application of complex data sets will find this useful. Algorithm types. Algorithm of brute force. The brute force algorithm is the most straightforward, but it is also the most applicable, eliminating incorrect solutions based on trial and error. Algorithm recursive. Recursive algorithms repeat the same steps over and over again until the problem is solved. Algorithm for backtracking. A backtracking algorithm progressively builds a data set of all possible solutions using a combination of brute force and recursive approaches. When a roadblock is encountered, the algorithm retraces or undoes its previous step and pursues other paths until a satisfactory result is attained. Avaricious algorithm. Greedy algorithms are used to source and select the optimal solution to a problem in order to get more juice for the squeeze. They typically extract the most obvious and immediate information in the shortest amount of time, allowing devices to quickly and efficiently sort through data. This algorithm is ideal for organizing complex workflows, schedules, or event programs. Algorithm for dynamic programming. A dynamic programming algorithm remembers the results of previous runs and uses this knowledge to produce new results. The algorithm, which is applicable to more complex problems, solves multiple smaller subproblems first, storing the solutions for future reference. Algorithm of division and conquest. This algorithm, like dynamic programming, divides the problem into smaller parts. After the subproblems have been solved, their solutions are considered and combined to produce a final result. Are algorithms capable of artificial intelligence? Algorithms define the decision-making process, whereas artificial intelligence uses data to make a decision. If a computer algorithm is simply a string of coded instructions for completing a task or solving a problem, artificial intelligence is more of a complex web made up of groups of algorithms that further automate this process. Artificial intelligence, by continuously learning from accumulated data, is able to improve, modify, and create new algorithms to produce other unique solutions and strengthen the result. The output is designated rather than defined, as with algorithms. In this way, artificial intelligence enables machines to mimic the human mind's complex problem-solving abilities. Artificial intelligence algorithms determine your Netflix recommendations and recognize your Facebook friends and photos. They are also known as learning algorithms, and they are classified into three types: supervised learning, unsupervised learning, and reinforcement learning. Algorithms for supervised learning. In this case, programmers feed training data, or structured data sets, into the computer, complete with input and predictors, and then display the correct answers to the machine. Based on previous outcomes, the system learns to recognize relational patterns and automatically deduce the correct results. Algorithms for unsupervised learning. This is where machine learning begins to shine. With unlabeled, or raw, input data, a computer learns to mine for rules, detect patterns, and summarize and group data points to help users better understand the data. The algorithm is used to extract meaningful insights from data even when the human expert is unsure what they are looking for. Algorithms for reinforcement learning. This type of algorithm learns from interactions with its surroundings, using these observations to take actions that maximize reward or minimize risk. Reinforcement learning algorithms enable machines to automatically determine the best behavior in a given context in order to maximize their performance. Algorithms of artificial intelligence in action. From artificial intelligence-powered smartphone apps to self-driving cars, artificial intelligence is profoundly changing our digital reality in a variety of large and small ways. Apps like Google Maps and Uber use location-based data to map routes, calculate journey times and fares, and predict traffic incidents. Artificial intelligence algorithms are working to improve our online experiences, from targeted ads to personalized shopping, while future applications will include self-driving cars and artificial intelligence autopilots. Uncover the data science secrets. Data is being collected at an unprecedented rate and scale, and it is becoming an increasingly important part of modern life. While big data is big business, it's useless without big insight. The skills required to develop such insight are rare, and the expertise required to extract information and value from today's data is in high demand.